My name is Faith. I am a lead system engineer at EPAM Systems. So today I will be taking you talking about AWS Cicd, specifically speaking about or making a case for Github Actions and CodeBuild as a runner. And technically just speaking around software delivery process best practices. And I would start with an introduction, of course, not going too deep into the Cicd because I think almost everyone here understands what Cicds are for, but I will just give a TLDR and then move on. Of course, selecting Cicd tools, speaking on Github Actions, CodeBuild runners, and general AWS Actions, apart from the CodeBuild action, of course. And then we'll do not a quick demo, but a very interesting demo. And then I'll take questions, and then we can see how we develop from there. So a quick word about me. I am an AWS community builder, specifically in the container specification. 4 times AWS certified. I'm also certified in Kubernetes. Enjoy working with containers and cloud native tools. And of course, I am a lead system engineer at EPAM. And let's jump into a quick touchdown about Cicd. So technically, what is Cicd? If you don't understand what Cicd is, it's continuous integration, continuous deployment, or delivery, depending on what you're practicing. So Cicd pipelines, they technically just help you automate your software release process. So you don't want to be building software on your computer or developers building software on their computers. You want this to follow a pipeline, and you want it to be visible to everyone. You want a defined process technically. So this is a typical Cicd pipeline. Of course, different organizations with different structures. But this is just, for example, from the source control, a commit passes through the code. The source code is built. Unit test is carried on that code. Integration test is also done. And of course, there might be a review process where maybe manual review, maybe automated pass-through, who knows? Of course, deploy to a staging environment and production. And this does not define, there is no standard definition for a CI/CD pipeline. You can adapt this as you wish in your organization, as you deem fit technically. Yeah. So before we proceed, there are technically fundamentals and checklists or best practices. This was actually extracted from the Code with Engineering playbook by Microsoft. Actually, CSE is a partner with Microsoft, and they released a very good engineering fundamentals checklist. Technically, a list of practices. I just extracted a few, but a list of practices that would help you in your organization keep a very healthy master branch, practices that would help you technically keep your CI/CD process very, very visible and top-notch. So first with merges, all merges will be done through a pull request. So PRs are pull requests. So that means the merge to the master branch has to follow a pull request. So a pull request will be analyzed and test will be done. So you cannot just push code to your master branch, for example. And pull request reference related work items. And of course, when you open PRs or pull requests, you have reviewers that would even maybe do manual reviews and or even maybe check this PR deployed to an environment, maybe some smoke testing. But then you, following best practices, you need people to review actually PRs that no one is just merging codes to the master branch. A second eye takes a look at it and maybe catches errors, maybe not. And while in the PR state also, linters, code analyzers like Sonar Cloud, run tests on these. Of course, you can also run unit tests, but again, the static code is analyzed or the PR is analyzed for even maybe secrets in that piece of code. Maybe developers are committing secrets. You want a tool that can check that for you. Technically, yeah, even offer security best practices, but technically also maybe do some linting, analyze your code, do some coverage and unit testing. And also with unit testing, you want to write unit tests that cover majority of your code. So CSE recommends over 90%, but in essence, I think anything above 80% actually makes sense. So again, you have to write unit tests or follow test-driven development that actually write tests that cover above 90% or 80% or even 70%, depending on the level of quality you want to keep. And when PRs are opened or created, you want to run, you want a pipeline that will technically take that PR, build it, test it, and even deploy it to an environment. And that leads us to the last point. So technically, you want a sort of a continuous deployment system that would deploy that PR or that piece of code or that change or that feature to an environment. And if you follow these practices, you will technically end up with, I think, or definitely a more LD master branch or a more LD main branch, if you don't call it master branch. And since we know these criteria, or since we know these best practices or checklists, then we have to choose a tool that actually helps us follow these best practices. Yeah. So we want to select a tool that has integration with a few source control systems, or actually the source control or version control system you'll be using. If it's Bitbucket, if it's GitHub, if it's GitHub Server, or even Bitbucket Cloud or Bitbucket Server, you want a continuous integration tool, for example, that actually integrates with that. And of course, we also, since we saw the importance of working in PR or PR style workflow, we want a tool that can actually enable this workflow. So technically, you can make a push to trigger the pipeline, which I think all CI/CD tools have. But then the uniqueness of having pull request event or pull request trigger actually a pipeline, and then of course the build happens, the test happens, and that PR is actually deployed to an environment. So we need a tool that actually supports PR natively. Of course, again, with developers, as DevOps engineers, technically, we enable developers. We make their life as easy as possible. So if you actually have a tool that you can, for example, have the code and the log from the build in one page or in less clicks, it's actually welcome. Not, for example, having your orchestrator or the pipeline orchestrator on one page, then you have, for example, the logs after 5 pages. So the more usable the UI, I think the better experience for developers, because of course, developers will live on these CI/CD pipelines. And again, of course, the biggest, I would say, caveat nowadays is having a fully managed systems are becoming popular. Yeah, we want a CI/CD pipeline that actually does not need extra management. That scales effortlessly. So we have 500 builds, or we have 30 concurrent builds. We want that CI/CD pipeline, or we want that build tool or that build server to be able to undo that concurrent build. So we don't. I think most people do not want to undo scaling of servers, or for example, you're running 300 builds and then your server dies, or you have to troubleshoot even the CI server or even the build server. And so technically it has to be serverless. Of course, serverless does not mean that there is no server, but it means that you do not manage that server. And a jab to Jenkins here, because of course with Jenkins, you have to manage that server. I understand there's Jenkins X, but this is just, I think, a joke on Jenkins here. So choosing that tool, we have a lot of options. There's no shortage of the CI/CD tools that you can choose from. You have Argo CD as a continuous deployment tool. You have GitLab CI as a CI/CD platform on its own. You have Jenkins X. You have Jenkins. So there are a lot of tools. And again, there are no, I would say, there are no correct or wrong tools. You just have to select a tool that actually matches your use case. And the problem with selection of tool actually then causes a problem. So how do we select these tools? We have those criteria, but then sometimes selecting these tools are not actually easy. And that's why when you, for example, work with a lot of AWS clients, just moving along with AWS CI/CD tools are just, I think, less strenuous. They are great tools, to be honest, and they do the job. They integrate very, very well with AWS services. For example, code commits, source control, or remote Git system. Does it work? Maybe does not have issues and project management functionalities, but it does its own work, or it does its work well as a source control system. And of course, CodePipeline, which is a orchestrator. AWS will call this a continuous delivery tool, but let's just call it an orchestrator, because on its own, it cannot do anything. It needs code build and code deploy to actually carry out its functions. But it does a very good work in tying around these tools and orchestrating the flow of actually our software delivery process. And the strongest of these tools, in my opinion, is CodeBuild. CodeBuild can scale to, I think, 1,000 concurrent builds, but it really scales. And for most use cases, CodeBuild will just be enough as a build agent. And also the size of the server you can actually provision is very large, yeah. And you can provision Ubuntu servers, you can provision all containers, because CodeBuild projects are actually containers. You can provision even Amazon Linux or Yum-based code build agents, yeah. And code deploy, of course, helps you with that continuous delivery or deployment as you may prefer. To AWS compute. So you want to deploy to EC2s, you want to deploy to ECS. CodeDeploy actually does a very beautiful job, and actually also deploys to S3 seamlessly without issues. So this there's a case for these tools. Technically, they do their job very well, and but there are issues. Yeah, no tool is perfect, of course, but there are still issues, especially with that orchestration layer, CodePipeline. CodePipeline integrates with 3 third-party source control systems. So GitHub, GitHub Server, and Bitbucket Cloud. So they are the most used source control version control systems. So it makes sense, yeah. And also, of course, integrate with code commit. But the biggest weak point, in my opinion, for CodePipeline is you can only trigger the pipeline based on the push action natively. So of course you can make a workaround on this. You can bundle your code to an S3 bucket and then make the S3 bucket trigger, for example, CodePipeline. Of course, when you open a pull request, maybe you have a webhook that's triggered. Sort of dirty workarounds to actually achieve a PR workflow with CodePipeline. But trust me, you don't want to go through that stress, or that stress might not be worth it, especially considering the alternatives out there. Yeah, so CodePipeline does a good work in tying around CodeBuild and CodeDeploy. Yeah, I think there's a case for this, and going forward, actually. So again, I say there are cons and there are pros for CodePipeline. Integration with AWS services is a big plus. Connection with the most used source control systems. Maybe not Bitbucket Server, but I think these 3 are one of the most used. I think GitHub itself has about 83% of the source control market share. So if you cover this, I think you cover a lot of the market already. But again, I told you about being the trigger being only a push action, which is a big minus. Pull request can work, of course, and you have to do some ugly workaround and have to build a system on your own just to that you have to manage just to achieve that workflow. So in comes the savior, of course, Github Actions. I'm sure you already know what the replacement would be from the topic of the talk here. So with Github Actions, I think there is a big case for replacement of CodePipeline, at least until CodePipeline provides a lot of these features that is missing natively. So with Github Actions, you can trigger a pipeline based on over 20 GitHub events, and that in itself is a reason to actually consider GitHub Actions. So you have a push to specific branches, and you can even have a sort of a regular expression of branches to even ignore or even accept pushes from, or that can trigger your workflow or your pipeline. You have pull request, native support, pull request creation, pull request closure, different actions that you can actually expand on using GitHub Actions. Maybe you make a release also, you can trigger pipeline based on those, and a lot of other actions you can actually act on. And of course, GitHub Actions is a CI/CD tool. That means it can build your code for you. It can also help you orchestrate that code and deliver that code to compute. So you can build your code with using GitHub managed runners. So GitHub managed runners are technically containers that come up in different operating systems, Linux, Mac, Windows, and even different architectures. So you have ARM. I think it supports ARM processors and x86, of course, natively. And you also have possibility to bring your own runners, and that's where I think CodeBuild makes a very big case. So you can bring of course, your runners do not have to be CodeBuild. It can be a server somewhere that you would have to again manage, which of course removes the fun from the type of system we are trying to build. Again, another strong point with GitHub Actions is creating reusable workflows. So reusable workflows or reusable pipelines are technically, for example, you have a way you build Docker images in your organization. You have 50 repositories and you build Docker images from those 50 repositories. Instead of having pipelines for each or writing full-on CI/CD pipelines for each repository, you can have a repository that technically houses your CI/CD pipeline, and then you call, or your other repository actually call that workflow. So you might actually have like 5 lines of YAML declaration of Github Action in each repository, and then you have the main bulk of the work in another repository. So it's really a big advantage of Github Action. So technically, you are able to declare your pipeline as code. So another strong point for GitHub Actions is the community support behind it. Of course, we understand that GitHub is big in the open source community, and even apart from technically independent developers coming around to make actions, which are technically little apps, organizations like AWS, like GCP, actually are coming out to actually make official actions that actually help you, for example, deploy to their cloud service. So it's really a strong point. And even tools like Sonar Cloud, like SecuCI, they have actual actions that you can use to for example, orchestrate your software delivery process. And of course, we cannot speak about a tool without speaking about security. So with security, GitHub Actions actually has a secret store in there. You can use the store secret, and you can actually manage secret by environment, which is again a very big plus. So again, I understand it's a new tool, and you have to understand, for example, how it works and what is the syntax around GitHub Actions. So with GitHub Actions, you technically have a workflow, which is technically, I would say, a pipeline. So each workflow is an instantiation of a pipeline. So on the left, you see a YAML declaration. So the name of this workflow is Learn GitHub Actions. And workflows actually contain jobs. So you see there's a job here, and you put the workflows in the .github/workflow directory. And as many workflows as you have there, GitHub Actions will actually read that directory and pick or actually display that workflow in the UI. And of course, you also have events, which I told you is a very strong point of using GitHub Actions. So events, technically, they are actual triggers that can trigger your workflow. So we've spoken about pull requests, we've spoken about pushes or issue creation, issue closure even, or releases. So those are events or actions you can actually act upon. And the job itself. So the jobs are technically the stages, I would say. So workflow can contain multiple jobs, can be one job, of course, also. And the jobs can contain steps. So steps are the actual, I would say, commands to run or call of actions to run your commands. Yeah. So jobs are a set of steps in a workflow that executes on the same runner. So when you declare a job, you specify where it should run, and then the all steps declared in that job runs on a specific runner. And of course, we have actions also. Actions are like custom applications or mini applications packaged that you can technically call. They're technically applications of frequent actions or repeated tasks that you do. For example, checking out code, or for example, even pushing to ECR, or technically frequent, or npm install. Not npm install, of course. Maybe installing a specific version of Node.js, and just common actions or common steps you would find in your CI/CD pipeline can be built to actions, and even your organization can build its own action. So another beautiful side of this is that you can fork an action and customize it to your own use, and your organization can technically even make this private if they want. Yeah. So with GitHub Actions, we can technically achieve something that looks like this. So this is technically, for example, an example of a PR workflow. Of course, you have to have your code in GitHub or GitHub Server, because GitHub Actions, maybe there might be an action out there that supports other source control, but we're not even thinking about that, because the power of GitHub Actions actually also reflects in having your source code on GitHub and the pipeline on GitHub. So you combine that, you have a very powerful tool. So in this case, we have a pull request workflow. Pull request is created, pipeline is triggered. You might want to run unit tests, or following best principles or best practices. You run unit testing, you build that source control or that source code, and then you deploy it, for example, a dev environment to actually see if it works or how it works. And for a typical part to production, I just mock this out. This does not, of course, this can be customized and changed as you wish, depends on the organization. So again, a push to the master branch or a push on the master branch triggers the workflow. And unit testing, of course, building, deployment to dev, to QA, integration test is run, maybe manual approval is needed before deployment to production environment, or you let everything flow. Depends on what you prefer. Yeah, so in this architecture, you can see that GitHub Actions technically replaces CodePipeline. And let's see a use case for this, or let's see the actual pipeline in action. So let's go through a quick demo. Before we move to the code itself, I have prepared a repository of, this is just an S3 website. Coming. Yeah, so this is just an S3 website, an Angular application actually deployed to a dev environment. It's an S3 bucket website, fleeced by CloudFront. I put a DNS in front of that. Of course, you can see that is actually dev.cloudacademy.demo, which is my own DNS.com. And I also prepared a production environment, which is actually cloudacademy.demo.com. So technically, I would demo a pull request workflow, show you how, for example, the actions actually look like when you trigger them. And I've prepared a couple of interesting demos for you. Yeah. So we can start with actual describing the pipeline. So this is a pull request pipeline. And if I take you back to see actually source code, because this actually has syntax highlighting, I'm using Visual Studio Code. It will help you see again what we're doing better. And okay, so starting with the first line, or let's go line by line here. We have the first line, which is of course you can this is a syntax, YAML syntax. You can structure this how you wish. I'm just going to follow from top to bottom, and you can structure this how you want. So this specific workflow is triggered when a pull request is created to the master branch. So of course, you create a pull request and you specify when you want that pull request to be merged. And once the pull request is created to master branch, this workflow is created. And in this case, you see there are two triggers or two events. And this is a workflow dispatch, which is technically a manual trigger of the pipeline. And then, of course, you have inputs that you can input, and you can actually use these values that you capture. And you see here that this is required, this is not required. And you can use this input in your CI/CD workflow, and then make use of the values here. So, of course, with GitHub Actions, you can also use environmental variables. So, environmental variable declared on the workflow level is available to all jobs. So env1, for example, is an environmental variable declared, and the value is workflow env. It's available to all jobs. And I will just collapse that. Let me leave it open. And this is the name of the workflow. Here we have, of course, you can name this anything. This is PR pipeline or pull request pipeline. And then we'll get to the jobs, which are the main works itself. So you see the jobs, I'm collapsing and opening them. They are the last point of the file. And we have a test job that technically runs unit testing on your source code. And of course, I've just put steps like commands to run. So technically, this is the checkout action that technically checks out that branch, or checks out that commit actually. And then I'm just running sort of just echoes here. But as we proceed deep, you see where I actually implement CodeBuild into this workflow. So I'm just going to make this very fast, so I don't waste the time. So I'm just running commands in place of actual unit testing. But if you have, of course, unit test in place, you can put this here and then make them run on these steps. So that's for unit testing. And then, of course, we proceed to the build. And then on the build, you see that we are actually specifying, and of course, on the upper job also, specifying where we want this job to run on. We want this job to run on the latest version of Ubuntu. And I think that should be 2022. Currently, I'm not sure. Don't take my word for it. But of course, again, this means that this job actually needs the test job to complete before it can proceed. And if it will only proceed again if the test job does not fail or is not cancelled. So I'm just trying to incorporate as much features as possible so you can actually see how robust this system is. So the build also has its own steps. And in this case, you can insert your own build steps. And now we get to the interesting part of actually using CodeBuild. I could have used CodeBuild in any of those steps, but I just want to make this short and fast. So on the deploy to actually the dev environment, we also we use Ubuntu latest to run the job, but the job does not actually run on Ubuntu latest. And you will see why I say that as we go. We have, of course, the conditions and the dependencies. So this is depending on the build. So I'll just collapse this also so we can see, yeah. So this is dependent on build also. So build has to not fail or is not cancelled for this to work. And now we have the concept of environments. You can specify environment and specify actual humans or people to approve deployment to this environment. And again, we have steps. So now with these steps, we're actually using CodeBuild now. So we have a checkout step, of course, to check out our commits. And then I have commented this out to show you that you can actually check out another repository. And of course, maybe you need a token also, and then you specify the branch you want to check out. But this is possible, showing you again the possibilities. And also just running an ls or a Linux command to show which files we're actually checking out. And here comes the actual fun part. So the next is the configure AWS Credential action. This helps us to configure, for example, credentials on or securely configure credentials on the runners to be able to, for example, trigger CodeBuild, because we need to be able to trigger that CodeBuild project. And the next part is actually the triggering of CodeBuild itself. So we specified name or the name of the step to be run CodeBuild. And then we specify the action we're using. In this case, we're using AWS CodeBuild run, and there's a syntax for this, and this means release version 1. You can also target a branch, I think. And this action actually expects some I would say some variables. And in this case, use the with keyword to specify the variables is request. And in the documentation, you can see this. It expects the project name. So you specify the CodeBuild project actually you're going to use. If you want to do a build spec override, of course, if not, it will use the build spec specified on that project. In this case, we're using the build spec from, Command Z. We're using the build spec from the .github workflow build spec and code deploy build spec, which is you see on this on the left. And we are passing in some environmental variables for the job for CodeBuild, and you can see here we are passing in custom. We are passing in, for example, environmental variables name custom, pull request number, UI bucket name, CloudFront ID, and I think I shouldn't have some of this here, but let's just pretend as if these are not there, because again, the main things we want actually here is just the bucket name and the CloudFront ID. So passing these, we are passing them actually as secrets. So these secrets are actually gotten from the settings itself. So if I go to settings and I go to secrets, I have a couple of secrets here, and you can reference these secrets from the Github Actions or from the workflow you're using. So I'm referencing those secrets. So my bucket name and my CloudFront ID are secrets, and I'm just calling them on. And of course, also you want to have this secrets access ID and then the secret access key also stored, like I have here. And of course, you give this user the least privilege. And in this case, I just need this to trigger CodeBuild. So CodeBuild trigger, it's enough. And with this, I've actually prepared, and actually I also have a master pipeline which does more, and we'll see as we go. So I have prepared a branch, and the branch is technically just going to change the color or the background color from I think sky blue to black. And currently you can see that in the dev environment we have a sky blue background. We'll just change that, and we'll see that workflow. So we'll create the branch. I'm going to pass the commit now. So I prepared the commit already. I saved these, publish change. And let's go to GitHub to actually catch this. And if I go to, okay, so even from pull request, I can compare and make a pull request. And of course, I will not change anything here. And you see a pull request to master will trigger the PR workflow technically. So let me create a pull request. And I've also integrated a tool called SonarCloud. SonarCloud helps you to do static code analysis, and I have not configured anything crazy here. It's just basic SonarCloud checks. So what happens is that SonarCloud will actually check my branch and see that the rules, for example, that you set or that have been set, that actually there are no even security vulnerabilities, no code smells, and just return a result, even as a comment on the PR page. And if we refresh, we can see that the action has started, and you see SonarCloud actually has done its thing. If we go to, for example, SonarCloud UI here, you can see that we have, okay, this is the last one. Yeah, so we have, it has passed the gates. I have not set any crazy quality gates. These are just default gates, and the code was analyzed and it has passed that gate. And remember, we are actually triggering this build from an action. we are triggering this workflow from a pull request creation, and you see instantly a workflow was created, and we actually did the unit test part. And if you go in, you can see the steps, individual steps, and you can actually see logs from those steps. And in the build step also, let me go back to the summary. You can see there's a build step also, and the build step again, you can see the different steps. A build job, you can see the steps. And again, let's go to the deployment to the development environment, which is actually calling running a code build, running on a code build project. And if I go to my AWS account, I can see the CodeBuild Action project, which we're actually using. So if I go to the workflow and see, you can see here that we are using the CodeBuild project, CodeBuild Github Action. So this is CodeBuild Github Action, and if we go to the run, you can see this was a run triggered technically some seconds ago or some minutes ago. And if I click it, this is actually the instantiation of a runner running our commands. And this is, of course, if I go to the build details, you can see the build spec is running is picking from the GitHub workflow build spec and CodeBuild directory, which is here. Or let me just show that from the console. I will duplicate this. So, of course, if you understand CodeBuild, you know CodeBuild needs its own build spec. And if we go to the workflow, build specs, and build spec deploy, these are the commands that CodeBuild will run. So technically, we are doing we are going into the source, or where the source code is located, doing an npm install, doing an npm run build CI, and then copying that build artifact to the S3 bucket responsible for displaying our website, and then we are invalidating CloudFront cache, of course, dropping old versions from the edge locations and then uploading new ones, or making the first person to trigger CloudFront to fetch new files for us. Yeah. So let's go back to see actually what is going on, and you see that CodeBuild is actually logging out or displaying the logs from CodeBuild. So developers do not need to actually even go to AWS to see logs, because if we go, we can actually tail these logs like you would do on CodeBuild, and you can see that commands are running. Do we have an error? Okay, I think we're safe. It's still running, I think. And we have logs output here. Like I said, you do not have to go into AWS to actually see the logs. They would be output here, and when it's done, you would see the stage has been successful. So remember the change we're trying to implement here. We're trying to change the background of the dev environment to black, and let's just see, or let's wait and see. Let's see how long it takes. But before we actually even see how long it takes, I can actually show you some phase details to see that because I know CodeBuild is actually notorious with having long provisioning time. But a quick, I would say, quick hack is for you to use a latest version of the CodeBuild image you're running. So if I go to build details, you can see we are running actually on CodeBuild standard 5.0, and we are looking to a latest version, and we're not just selecting to an older version. So that helps provisioning time technically. So you see, we provision in technically 27 seconds, and our pre-build is taking a long time. Maybe we have to optimize that. The build itself took 27 seconds, and this has succeeded. You see, it's a success message. And if we go back to GitHub Actions, you see we get the same success message. And if we go to the summary of the pipeline, you can see success message. So let's try to see if the actual change was effective. Okay, I think this is this is the change we were expecting. I was expecting a full-on black, but that's not important. It's different from what we had initially. So maybe the color code actually was not full-on black. It was black blue. I don't know what to call this. Yeah. So you see, but this is technically not affecting the main pipeline. This is only deployed to dev, or not affecting the main environment. And you can see now another, for example, another user or another developer can actually review this PR, and you can see all the gates we set for it was actually successful. I think a configuration actually was missing. Because part of those best practices is actually to protect that branch, and also to set, for example, necessary checks that need to be passed. Yeah, we set that. Okay, so it was successful. So you see in the settings for the branch, so that's master branch, we are protecting it. we can only, for example, I've set up a rule that actually requires a pull request before you merge. So without this pull request, you cannot merge. And in normal ground, I would also set a pull request approver and maybe select 2 people. But since I'm the only one in this account, I will just not get anyone to approve that. So also require statuses to check before merging. So I want Sonar Cloud Analysis to check, to be successful, and also unit testing to pass, and build, and then deploy to dev to pass before anyone can actually merge to the master branch. And so now I think we have achieved those requirements, and we can now make a merge. We can merge the pull request technically to the master branch. And once we make that merge, the main pipeline or the master pipeline is triggered, you see? So it technically shows the branch is running on, and then the SHA, of course, the SHA in this case is the last commit, or so we change the color code to reflect, I don't know what color code this is, but it's showing blue black. Maybe someone knows this color, can maybe put in the comment, I don't know. But again, this change is getting deployed to production, or is actually our master workflow is being triggered now, and you can actually see, okay, very similar to what I had in the PR workflow, unit testing and build are actually just echo commands, and then deployment to dev again. Maybe you want to skip this because again we have that code already deployed to dev, and you see with every trigger or with every deployment, a new code build instance or container actually comes on to take that job, you see? So we can actually scale this to infinity. Of course, there's a limit to concurrent builds you can have by AWS, but if you lift that, you can technically, I think, achieve high amount of concurrent builds here, and we can, again, follow the same process that we followed the last time, check the logs. But the good part of this is that your developers can actually follow the logs just in here without actually coming out. So code build would log out. And while it logs out, you can also see Sonar Cloud also does a sort of analysis, and you see 2 minutes ago. So when there's a change on master branch, I've configured this to, of course, work like that. When there's a change on any of the branches, or when there's a pull request, Sonar Cloud will run analysis on that and detect code smells or bugs or security vulnerabilities. It's a good tool to have in your pipeline, and I know there are hundreds of tools out there again that can actually do this. So you would, if you have any issues, and in this case there are some. Again, I didn't configure this to be. I didn't configure Sonar Cloud to actually pass this test. It's just to show that we can actually incorporate Sonar Cloud into our workflow, or incorporate other tools into our workflow, even using Github Actions. And again, we have those logs logging out now, and in some minutes we should have deployment successful. If I go to actions, okay, we can have a top view of this pipeline. So we would deploy to dev, deploy to QA, do some end-to-end tests. End-to-end tests in this case, again, are just commands, because I don't want to run end-to-end tests, or I don't have end-to-end tests actually set up. It will take time. Integration tests run, deployment to production runs, and yeah, we would wait while that happens actually. And I've showed Sonar Cloud. I can take the time to actually why this deploy, to show you other cool stuff, or AWS Actions. I mentioned Actions initially. They are technically mini applications that you can use to build your workflow, or to build or steps you can include in your jobs technically. So this is officially from AWS. Oh, sorry. This is officially from AWS. So they have different actions here, and I think in the future they would even come out with more actions. So for example, this action cleans up stale issues from your repository, and yeah, that's what it does, cleans up stale issues. So if you have a repository and you want to clean up stale issues, you can use this official AWS action. This is another one to technically render ECS tags definition to your repository. So maybe, I know when you want to do ECS deployment, you need that task definition, and this can be a prior step to actually generate a JSON file to render that task definition file for you, and then ECS deploy task definition can take that up. And of course, Amazon ECR login. For example, you're building Docker images. You want to push that Docker image to ECR, and you're actually building that Docker image on Github Action. This is a very good action to actually use. So it logs you in securely. oh, sorry. It logs you in actually just to ECR. So this just logs into ECR. So this logs you in securely to ECR and actually probably also deletes that credential. I have not, I think I have a project using this. Configure AWS credentials. So this is general AWS credential configuration for uses with other actions, maybe even just making CLI commands with GitHub managed runners. So you would need, for example, to configure a secure way to configure or to configure credentials for your workflow, for your job. So this is something you can use, and we're actually using this in our pipeline. If you see, the next is ECS deployment or ECS deploy task definition. So once this generates that task definition for you, or if you have that task definition JSON file in your repository, you can use this to deploy it to ECS, and you probably just specify the cluster, specify the service maybe, or even the task definition name, and then does deployment for you. And the cool thing about this, actually, it has an option to wait for the service to be available or to be stable before pronouncing deployment complete. So very cool action. And this is the one we're using currently, or we're focusing on heavily, is the CodeBuild run action, technically to be able to call CodeBuild projects from Github Actions. And we have a lot of them. So EKS Fargate, CodeGuru Reviewer, another tool for static code analysis. Actually, an AWS service also, CodeGuru. Cool DevOps tool, set up some close issue message. So you can have different actions, and even if you go to the marketplace, so if I go to marketplace, I can have actions. Yeah, so you see there are lots of actions you can actually use in building your CI/CD pipeline. This is by MATLAB, by Red Hat, by GCP, or by Google. So you have lots of actions to work on, and you see this is by Snake, or what do you call this, SNYK. I know they are a security tool also for CI/CD pipeline. So you get the point. There are lots of pre-built steps for you that you can just call and implement in your pipeline and make your pipeline very robust. So let's check on our CI/CD deployment. So we have deployed to dev, and of course we still have that old deployment that we had before, because we already deployed this to dev. We are now deploying to QA. Deployment to QA probably almost also done. So it's running on CodeBuild also. And again, deployment to QA, again, is calling CodeBuild. You see, it's we go back, we can actually also catch that. So we are not scaling the runners. They are scaling on their own. They are scaling technically independently of our actions. A new instantiation comes on. And yeah, another cool thing is that, oh, sorry, I think I've made this too big. Okay, perfect. So you see, this is technically running for the QA environment. And if we go to environmental variables, another powerful aspect of this is that the CodeBuild action actually just dumps a lot of environmental variables for us to use. So the repository name that we're deploying, okay, these are secrets that I've configured. GitHub server URL. Of course, the API endpoint. So you can actually use these environmental variables in your own workflow or in your own CodeBuild build spec. So you see, even the person that triggered this, Fitosin, which is my username, you can also see the branch or the ref name. You can see the run number. You can see technically the retention. So a lot of information to play with. And you can see technically the run attempt. If this was failed before and you're trying for a second time, it will show here. You can see the workspace. So it's a lot of information to actually play with. So just without calling any APIs, without doing any manipulation or JQ manipulations, you have a lot of environmental variables to just pick from. And let me go back again. Is this successful yet? Maybe not yet. And again, why this goes, let me briefly just introduce or show you another cool feature. I know I've been saying a lot of cool features, but this is actually would be, I think, a very nice one. Let's go to the GitHub workflows. So I have technically 3 workflow files. So I have the PR one. Okay, let's do this from where we can get syntax lighting actually. So again, you can see my file structure here, but if you cannot see this, let me just see into the GitHub directory. I'm actually already in the .github directory. So let me just run the tree command, and you can actually just see that I have a workflow folder. And in that workflow folder, I have the main pipeline.yaml, PR or pull request pipeline.yaml. I also have this caller.yaml. And I have build specs, of course, used by my CodeBuild jobs. So I want us to focus on caller.yaml now. And I drag this back down. So I've actually made a caller YAML file for the PR, for the pull request pipeline. So with the pull request pipeline, you see that we had these lines. How many lines is that? Let me go and... So technically, we had 91 lines to declare that workflow that we just saw. That means we use 91 lines to declare this workflow. So if I go to the PR pipeline, we used 91 lines to declare this workflow. Imagine I have, for example, I'm an organization that actually deploys to S3 a lot. I have maybe 50 repositories. I do not want to have this, or there's actually a better way to have, for example, a workflow without declaring them 50 times, or having a central place to manage that workflow. And if you remember, I mentioned reusable workflow. So I have turned this PR workflow into a reusable workflow. And actually, you can find that in this repository. I created a new repository, reusable workflows. Of course, I made the necessary settings, because for you to reuse a workflow, you have to go to the action settings and allow, read, write permission. I think that's what you can consult documentation for that. Probably skipping something. But technically, you can find the workflow to be called here. And you can see the workflow to be called as an action called workflow dispatch. No, sorry, workflow call is what we want to be looking at, because workflow dispatch is actually a manual trigger. So workflow call is an action that actually specifies that this workflow can be called by other workflows. So I specify secrets to be passed on, or and also an input, which is a variable also that should be passed on. And I've declared a test phase, a build, and a deploy to dev. So instead of having this in my main repository, I can have this in a code or reusable workflow repository, and call that from my main repository, which is we'll see here. So I have a caller workflow here, and just use this to call that workflow. And in 18 lines, we get the same effects like we had when we used, for example, when we used how many lines? When we used 90 lines. Yeah. So I'm calling the workflow. The workflow is in this repository, if you remember. Feitosin is the name of my account, or your organization, as you might be using. And of course, the repository name, and then the directory where the workflow is called. You have to put these workflows, of course, in the workflow directory in the .github folder. Yeah. And of course, you specify the name of the YAML file. In this case, we have called. So let me move this closer, and you can actually see. So the name of the workflow is called, and the branch is master. You can actually also call map releases, but here we're using the master branch. So you see, I'm calling this workflow. The workflow expects secrets. I'm passing that secret on, so it expects secrets. So these are the secrets it actually expects. So it expects of course the secret it needs, and it also expects a variable, which is in this case just env. So we can see it expects an input, which is env here. And now a lot of other repositories can actually call that workflow, and we can achieve the same thing. So because I don't want to go through creating a pull request again, I will just trigger this workflow manually. So I'll go to actions, and actually go to prod. Oh, this is waiting for approval. Okay, actually, before we go, let me just call our workflow, run workflow, and you can see you can specify the branch you actually want to run on this workflow, or on called workflow. So I call this workflow, and this workflow, if I refresh again, it's taking some time to start. Okay, from 18 lines actually calls the other workflow and builds out. So it starts building out instantly. So let's go back to our main action that we were waiting for, which is in the main pipeline. And you see that it's deployed to the QA environment, end-to-end test has succeeded, integration testing has passed. And now production, of course, maybe you want continuous, or you're practicing continuous delivery and you want manual approval. So using that environment action or environment option that we actually can find here. So I take you back to the main pipeline. Sorry, I'm just jumping around, but I have little time to show you this. So in deployment to production, I specified environment, which is prod. And without the environment prod, if we come to settings, you can actually see environments. And here I've configured, of course, prod, QA, and dev. So with prod, I have a protection rule. And let's see the protection rule. The protection rule states that I need approval from myself, of course, to deploy to this environment. And you can have complex protection rules up to even specifying which branch you can actually deploy to production. So if, for example, we can say for protected branch, okay, you can specify. I was going to specify master to be deployed to protected branch. Okay, yeah. So I think master branch can now only be deployed to the prod environment. So let's go back now and approve that. Go back to actions. Of course, this is the one. And then if you see review deployments, I can accept and say approve and deploy, and deployment to production starts. And if you remember, we have our production our production endpoints as cloudacademydemo.com. Currently, we have it to be blue. Dev is already blue-black. I don't know what to call this. So once deployment is successful, we should see blue-black here also. And going back to reusable workflows, so we have two workflows or two runs currently running. So the caller workflow, like I said, is just 18 lines calling a workflow in this repository. Calling this workflow where we have 85 lines, and other repositories can also call this and make use of this simple workflow. So a use case for this is in an organization. You can have a repository where you manage your workflows, and then you make changes here. For example, you want to change the CodeBuild job, you change it from here. Or maybe there's a new version of CodeBuild Action. You change it from here, of course, after doing some tests, and then all other repositories automatically inherit that change. So let's wait for our deployment to production, and I think we can start taking questions at this point. Okay, just a few minutes. I think we'll be done, and then we can see deployment to production. Yeah, let's wait.
Okay, right. Few minutes we will be wait for this. Maybe.
Yeah, no, I think some seconds. Yeah, it won't take long.
Okay, so maybe wait, or you want to answer some questions, because
we can take questions as we go. Let's take questions.
Okay, so maybe Stefano the first. Okay, you should see it on the screen.
Okay, so Stefano says, how are exceptions handled? So he says, for example, an event goes in error. How can I send notification to someone to let them know what has happened? Or are there specific actions that deal with that? So actually, very great question. Of course, with every CI/CD pipeline, there are a lot of things to be configured. And you see the notification section here actually allows you to configure notifications to, for example, on different events, what happens if there's a failure. By default, I created this pipeline, an event I actually sent to my email. I don't know if I can pull this up to show you an example, but trust me, you can, let me try to, for example, try to show notifications from previous GitHub failures. Okay, I rather not show my email on the live broadcast, yeah, but you get the point. Notifications can be configured from here, and then you can specify the email address of people you want to get notified when specific pipelines fail. By default, it will notify, I think, the admins or the creator. I'm not sure, but yeah, notification comes, of course, out of the box with GitHub Actions, yeah. So I hope I've answered your question, Stefano. You can put a follow-up if you think you have more follow-up questions. So let's go.
Okay, so I have another from Vanessa.
Okay, so Vanessa says, how is the GitHub authentication settled on AWS? Yeah, another great question. So of course, you understand with AWS, there are, I would say, a way you allow, or you deal with permissions and accesses, especially from external entities, is to create, for example, IAM users. In this case, we create an IAM user in AWS, and you give this user the permissions you actually want to give it. And if you go to the AWS action page, you can actually see for each action, you can see the sort of policy you need to trigger or to use that action. So in our own use case, we have the CodeBuild run. Let's go to the documentation, and you can see the policy file is already here. So you create an IAM policy that allows for you to get log event, of course, because we are streaming out logs to GitHub Actions, and of course to also allow you to start build and batch get builds. So if you configure that the IAM user, you give the user these permissions, and then you actually use that secret in triggering your workflow. And in this case, if I go to settings, you can see that if I go to secrets, the permission we are using, which is the access key ID and the secret access key, are actually tied to a user. So GitHub actually inherits the permissions from that user. So I don't want to open my IAM console, but I'm sure you get what I mean. So give list privilege, and that again is another appeal from GitHub Actions, that you can specify just what you need the code build or the code build runner to do. You can specify what you need GitHub Actions to do. In this case, trigger code build, and then code build can, for example, have access to S3, have access to DynamoDB, to Lambda functions. So it's another. I think it provides another security, another layer of security for this sort of setup. Yeah. I hope I've answered the question, Vanessa, and I think our actions are actually finishing. So let's see actually our actions finishing. So the main pipeline deployment to production is successful, thank God. And if we refresh this, we should get blue black. Yeah, so you see we get the same blue black, and you can scale this to as many environments as possible. You can scale this to as many use cases as possible. And again, the called workflow also I see also succeeded. So let's go to caller workflow. Also succeeded. Yeah, so it deployed to dev. Okay, yeah, so it deployed to dev. Yeah, so let's take more questions.
Okay, we don't have more questions.
Okay.
Okay, but I'd like to ask, if you have any question, please write in comments, and the Fate will answer. Oh, yeah, it's another one. I put it on the screen.
Okay, so Chiemere is asking if it's possible that you can actually create a role for GitHub to assume instead of creating an IAM user. So again, if you understand the concept of roles and users in AWS, you understand that only AWS services can actually use roles. Maybe in specific situations where the vendor has a way of attaching roles to what's it called? Attaching roles to their service, but in most cases, once external services or external applications wants to call AWS, you need a user. So that user would have a set of privileges or policies attached to it, or maybe even in a group, and then you use that secret key or access key ID to actually make this to work. And again, going back to the AWS actions, you can see that configure AWS credential is the action that we actually use. So you specify, okay, it actually allows a role to assume. So this actually improves on assuming role, but you still have to specify configure credentials. Yeah. So if we go back down, oh, I think this is a different. So let's go to CodeBuild. So I'm sure you have to actually configure a user for GitHub, and again, go with list privilege. If we go with so you use AWS action to configure, and then you provide a secret key and an access key. Of course, you specify a region, and you pass this on as secret. They are what's it called? Securely passed on and terminated. If we go to the logs of our build, let's go to the logs. You can actually see where they are terminated or where they are gracefully removed. So post checkouts. Okay, so post configure AWS credential. So it cleans up that credential actually. So it's not kept on GitHub runners. And if they actually kept on so let's imagine, because we also have to imagine the worst case. So imagine we lose the credentials we are using for GitHub. The only permission attached is to trigger builds, and that's all the person can do. Of course, you don't want to lose credentials in this case. Yeah, so I think this is very secure and provides a very good layer of abstraction to AWS services and our AWS or IAM users, yeah, or credentials technically. Yeah.